to measure the equivalent circuit parameter, that means Rx, Xm and Rc, we will have to find out how it can be measured just by circuit analysis. If you just look at this, what is R? R is equal to R1, that is the resistance of the primary, plus alpha square R2. That alpha is the turns ratio of the transformer. So, if I look at this equivalent circuit, if I make this transformer open circuit, that means at the secondary I am not putting any load, it is just open. So, there will not be any load. So, then how much is the impedance? When it is open, its impedance is infinity. That means, whatever value of R2 is there, its value will be infinity. That means, this R value will be very, very large, tending towards infinity. So, no current will be passing through this branch, and it is very apparent also when this terminal is open, no current can pass through the branch. When no current is passing through this branch, we can forget this branch. That means, I can omit this branch. So, if I omit this branch, now you look at that it is just a simple, that means, this is the circuit transformer on no load. This is the equivalent circuit of transformer on no load. So, under no load conditions, transformer only driving this voltage, applied voltage will be driving only the magnetizing current I0. So, in the transformer, if I make the secondary side open and give a voltage at the primary, that voltage should be the rated voltage, whatever is there in the primary. If we apply that, then full flux. Why rated voltage? Because in our earlier lecture, we could understand that the working flux inside the transformer depends on the applied voltage. That means, the more will be the voltage, the more will be the working flux in the transformer. And our this element, that means, this core loss completely dependent on the flux. So, full core loss I will get the value of the resistance, which is getting represented by this resistance, if I apply the full flux across the transformer. So, if I give a full voltage, that means rated voltage at the primary, then I can develop these circuits and I can find out the current. So, what I will do? This is my transformer. This is my transformer. Secondary side, I will keep it open. Primary side, I will give a voltage. To vary this voltage, that means, to apply the rated voltage, I need a little variation of voltage. So, I should use a variac here. So, this is a variac across which I will give the voltage V. This variac will be connected to this circuit. So, I can apply the variable voltage to the primary, so that this voltage will be the rated voltage. So, I should measure this voltage, how much I am giving. So, I can put a voltmeter here to measure the voltage. Then I will have to measure the current. If I want to measure the current, I can just put an ammeter here. So, let me put an ammeter in the circuit to measure the current. I am keeping the secondary open. I can put one voltmeter here also. You know, the impedance of the voltmeter is very, very high. So, this voltmeter will not disturb the open circuitness of the secondary. This voltmeter I will get. Then how can I do now? What I will do is I will measure the power consumed by this magnetizing current. When core is getting magnetized, how much power is getting consumed. So, I will put an wattmeter here. I will put an wattmeter here. This will be an wattmeter. This is an wattmeter. So, I will put an wattmeter here. So, what I will do now? If this voltage is V1, if I say this voltage I am measuring is V1, this voltage I have measured V2, then my voltage ratio alpha will be equal to V2 by V1. Mind it, I am applying the rated voltage here. That means for it is 11 kV transformer to or 415 volt, I will be applying 415 volt here, rated voltage. And there I will find how much is the voltage. It should be 11 kV. So, V2 by V1 will give me the turns ratio of the transformer or voltage ratio of the transformer. Then, from the wattmeter reading, if W is the wattmeter reading, what is W? W is V0, whatever I have applied V1. If the current I take it is I1. So, V1 I1 cosine phi. Cosine phi is the power factor of the transformer. So, Vi cosine phi is the actual active power which is getting consumed in the transformer. So, from here I can find out what is cosine phi. Cosine phi is equal to W by V1 I1. From this value of cosine phi, I can find out what is the value of sin phi. Sin phi will be equal to root over of 1 minus cosine square phi. So, now in this parallel circuit, the current flowing, this is if it is I0 is the current which I am measuring. This measuring is I1 I am telling here. So, I1 is the current now. So, I1 is getting divided through the resistance I1 cosine phi current will be flowing and through the inductance I1 sin phi current will be flowing, because I1 sin phi is the reactive current. So, it is passing through the inductor. So, it is a completely reactive current, ideal reactor. So, completely reactive current, this is the ideal resistance. So, it is completely resistive. Its current will be I1 cosine phi and I1 sin phi. So, from there, as soon as we find out cosine phi, that means power factor angle of the transformer, and sin phi, I can say that IEM magnetizing current is I1 sin phi and loss current or resistive current, that means core loss current is I1 cosine phi. From this, if I know this is the I1 sin phi, this is I1 cosine phi. So, if I know these two values, then what is the value of Xm? Xm value will be this voltage V1 divided by this current I1 sin phi. And what will be the value of RC? RC will be V1 by current, that means I1 cosine phi. The I1 cosine phi is current is passing through it. So, with this experiment, that means keeping the secondary side open, if I do this the experiment, measure the voltage, apply the rated voltage, please mind it that we will have to apply the rated voltage to generate the full working flux, so that this full magnetizing current I could measure by this ammeter, and then by this voltmeter. If I take the reading, I can find out the cosine phi taking the wattmeter reading into account, and then I can find out IM and IC From there, I can find out Xm and Rc. So, by doing this this is called open circuit test of the transformer. By doing this open circuit test, I can find out the shunt parameter of the equivalent circuit. In the next lecture, we will discuss how to find out the series parameter, that means resistance and leakage reactance of the transformer.